So this is a final project presentation for MIS 665 by Nicholas Spiller. It is on IMDb movie scores. We are determining whether or not a movie will be good or not. Will it have a good score or not? So to start off, I wanted to give my thoughts at the beginning of the analysis. At first, I thought that the best variables that were highly correlated to an IMDb score, determining whether or not it was high or low, I figured that the best variables were genres, the cost of the film, or the actors and directors that were in the film. These were things that I felt like were the most important because they're things that I look for in movies. But as you go along with the data, that actually was not the case for the IMDb scores. So first off, we wanted to read in our data. As you can see, we've got lots of different variables here, like the genre, keywords, the link to the film, the title year, things like that, Facebook likes. And then we wanted to look at description of the data. We wanted to see exactly the average for all films that are on the website. We wanted to see what data we were looking at. So you can see the count of data points, you can see the mean, the standard deviation, all these numbers that we've got here. And it gave us a generalized feeling on the data that we're working with. So next, I wanted to see what type of data points they were. Some of them are objects, some of them are floats, some of them are ints. Obviously, we can work with floats and ints much more easily than objects, but we can work around that, and you'll see that later on in the project. Then I wanted to see how many values were null. Later on, there is some analysis that we cannot do with null values, so we would work around those and work with how we're going to work on those in our data preparation and within those analyses. Here next, I wanted to see the counts, the most common movie in some of the value counts of variables that I felt were very important. So I did genres, director name, and actors. So the most popular were drama, Steven Spielberg, Robert De Niro, Morgan Freeman, and Ben Mendelsohn. So next, we wanted to fix some blanks in the data. So I would look up either the most common of a category or the average if it was a numeric value. So here with color, it was color was the most common as opposed to black and white films. Here 107.2 was the average duration, so we filled in blanks with that. And then the most common language was English. And then here I felt like some of these values were not needed based on analysis and looking at the data and also looking at the correlation analysis earlier. And I was able to determine that some of these were not the most important factors in determining whether or not a film was going to have a good score or not. So now we can go forth with our analysis with our best guess as to what the biggest deciding factors are going to be. So now we're going to do a little bit more analysis. So we were able to find out which movies, genres were the most successful based on their gross sum. So we could just see what genres, what movies, what actors and directors were the most successful and had the best scores. So as you can see there, Avengers was the highest, action, adventure, sci-fi. It's probably Avengers, so there you go. Gross profit was the highest there. As you can see, one of the more common genres was actually comedy, so I wanted to look at some of the data for some of the comedy films. As you can see, we've got 10,000 BC, The Campaign, The Hangover 2, Grown Ups 2, Jack and Jill. And they've got some popular actors as well: Will Ferrell, Bradley Cooper, Al Pacino. And we move on to the gross sum per movie title. We got The Hangover and The Hangover Part 2. Obviously, you can see that those types of movies, trilogies or two-parters, they tend to do very well. And then here's the most successful by score, John Blanchard. And you got the most successful movie by score, which was Towering Inferno and The Shawshank Redemption, some classic films. Same thing here. These are the lowest scores. Some films that, like a documentary, and other things. Then here you can see the best scores based on country. You see Kyrgyzstan is actually the highest, then Colombia, Finland. Then we've got the title years and their scores, and then here one thing that we were able to determine is the movie Facebook likes are going to be very important. So I looked up the Facebook likes based on movie titles, and Interstellar was by far the highest. So I've determined that some of these are. I also was able to determine these factors were important based on a website by Chuan Sun. He labeled out what makes a successful film, so I wanted to test these variables out as well. So first up, we did our correlation analysis. So we did this fancy little code here to do the correlation. And what we're looking at is the IMDb score specifically here. We can see these values. As we can see, the highest value is actually right here. And as you can see, it's num voted users. That is the number of users that voted on the film, gave a score. And that means in our analysis we can determine that that is the most highly positively correlated for IMDb score, and the most negatively is right here, the year that the film came out in. So we can determine that that is actually going to most negatively affect films. Here's a more colorful way of depicting that, but as you can see right here, at the 0.4 IMDb score, down there it's going to be num users voted, and then right here we've got the title year. And that's reiterating what I just said. So next we did our regression analysis, and at first I wanted to see what types of variables we had yet again. It allows me to get more proper data. And we did a linear regression model. We obviously are using IMDb score and then all the other variables. So then here's the mean square error for the first, our linear regression model. Then we have a regularization model, which has a little bit better scores, but then the best one was our feature selection regression model, which had much higher mean square error and variance, or much lower variance, which means it has much better scores. So it means that we want to use that model when we are determining whether or not a movie is going to be successful based on score in the future in our regression. Next, we want to do a classification model so that we can determine if a title is a movie title or something else. So I was able to get data from both movie titles and HR titles, and I compared them using labels of 1 and 0. Then we tested 3 different models: naive Bayes, K-Neighbors, and support vector machine, which had the highest scores, which is the one that I decided to use to test the model. And based on our results here with an HR model, an HR article, and then a movie article, I was able to determine that the model works and it will calculate accurately whether it is a movie title or not. So next we did clustering. We wanted to put create different clusters. So first we had to normalize the data so it was more accurate with less variance. Then we put it into a k-means algorithm so that we could use it to then create two different clusters, cluster 0, cluster 1. Cluster 0 is less successful films, 5 and under, and cluster 1 is successful films, 5 to 10 score. As you can see, these scores, you can generally see that ones have much higher critics, more Facebook likes, higher gross profit, more users that vote on it, and more face views, more reviews, higher budgets, and obviously the average score, which shouldn't, you can see that it is much higher as well. And in the end, we have created a regression model that allows us to predict what an IMDb score will be in the future. We have a excuse me, we have a classification model that allows us to find movie titles within different reviews so that we can accurately find a movie title and not be doing analysis on something else. We also found out based on correlation that the more reviews there are, generally the better the score for the movie. And lastly, we found out that there are much more lower scored films than there are higher scored films based on our clustering analysis, based on k-means algorithm. And we found out that 5 and under scores are more prevalent than 5 and over scores. And that's about all I have for you.